edition of Math for No Reason. In this edition, we are going to solve this problem. How many bijections F from 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5 are there such that Fi is not equal to I for all I equal to 1, 2, 3, 4, 5. Now, if we have a bijection from 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5, then this essentially is a permutation. So F1, F2, F3, F4 and F5 are an rearrangement of 1, 2, 3, 4, 5, and hence we can think of F1, F2, F3, F4, F5 as a permutation of 1, 2, 3, 4, 5. So how many permutations are there? So we know that the number of permutations with 5 objects is 120. So number of bijections is 5 factorial, which is 120. So 120 bijections are there, out of which how many satisfy the condition that Fi is not equal to I? This is what we are going to study. Now to study that, let us suppose A1 is the set of all functions f such that f1 is equal to 1. So all these functions are functions of 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5, and we are putting this additional condition that f1 is mapped to 1. A2 is similarly all those functions which have f2 is mapped to 2. And similarly, we have A3 where these maps F3 to 3. Now, how these sets A1, A2, A3, A4, A5 relate to the counting of the maps with this property? Now, note that all the maps which satisfy this property Fy not equal to I are not there in this set. So, what we will do is we will count the number of elements in the set A1 union A2 union A3 union A4 union A5, and then we will subtract this quantity from 120. The resulting number that we will get is going to be the number of maps which satisfy Fi not equal to I. So any map which is there in this set has at least one of its elements mapped to the same number. So all these elements which will be there in A1 union A2 union A3 union A4 union A5 will not have this property. So that's the key observation that we have. Now we will use the principle of inclusion-exclusion to obtain this quantity. And we know that this will be first the number of elements in each of these sets individually, then from which we will subtract the number of elements in AI intersection AJ, then we will add all the triples, then we will subtract all the quadruples, and finally we will add the intersection of all these things. So this is the principle of inclusion-exclusion, and we will use it to obtain this number. So what is n of AI? Now in AI, one element is fixed and anything can happen to the other 4 elements. So the number of possibilities is 4 factorial. In n of AI intersection Aj, 2 elements are fixed and the remaining 3 can have all possibilities. So that is 3 factorial. N of AI intersection Aj intersection Ak have 3 elements fixed and the remaining 2 can interchange. So the possibilities is 2 factorial. And for N of AI intersection Aj intersection Ak intersection Al, we have 4 elements fixed. But if the 4 is fixed, then the last one is also fixed. So there is only one possibility. So to calculate N of A1 union A2 union A3 union A4 union A5, we have the first one is there are 5 terms in the first summation. So we have 5 into 24. In the second term n of ai intersection aj, there are 10 possibilities. 5c2 terms there, and each of them is 3 factorial, so 10 into 6. For the third term here, we have 5c3, which is same as 5c2, so there is again 10 possibilities here, and each of them is 2. And for ai intersection aj intersection ak intersection l, there are 5 possibilities. 5c4 is 5, so 5 into 1, and finally we have plus 1. So we get 120 minus 60 plus 20 minus 5 plus 1. So the number of elements in this set f such that fi not equal to I for all I equal to 1, 2, 3, 4, 5 is 120 minus 76, which is 44. So there are 44 bijections from the set 1, 2, 3, 4, 5 to the set 1, 2, 3, 4, 5 such that fi is not equal to I for all I equal to 1, 2, 3, 4, 5. That's a good place to start. Thank you.